In this video, we're going to look at our first property that we have of geometry of straight lines, okay? And that is, if we are working with a straight line, or we are given a straight line, and there are different angles on them, okay? That sounds very weird. So, for example, like AC is a straight line. There's another line crossing it, and then you see this line crossing here, meeting at vertex B, creates two angles, and we call these angles angle B1 and angle B2. Okay, they put the 1 and the 2 there just to help you with naming conventions, because otherwise you would have to call them A, B, D, and D, B, C, which is a lot more to write than just B1 and B2. Okay, so do you see there's no degree symbol there, so it's not like the actual size or whatever. So then this angle and this angle, because this is a straight line, we know a straight line is 180 degrees, a straight angle is 180 degrees. So then when we add these two together, we are going to get 180. We're going to look at how we use that in a moment. And the reason for that, and I'm going to quickly write it out for you here in words, is they are angles on a straight line. And that's the abbreviation for it. And you can just abbreviate. You'll find mathematicians are often on the lazy side when it comes to writing. Okay, there's a reason why we're not teaching languages. Anyway, so angles on a straight line is going to be your reason, and you can abbreviate it. Just note the angle symbol has to be a little bit skiff, not that, please. Anyway, and then we also have the converse of this is the theorem or the property. In maths, we talk about converse of a property, which is the opposite, the inverse of the property, is if we tell you, or if you go calculate, that when you add up these adjacent angles, it gives you 180 as an answer. So for example, you got 50 and you got 130 for the two angles. Then because it adds up to 180, you can deduce, or you can prove, or you can show that ABC, okay, do you see there's no angle now? Because if there's no angle, we're talking about a line segment. Then line segment ABC is a straight line because the adjacent angles are supplementary. So this is our first property, and it's converse. Now we're going to go look at like examples of how we use this property or how it can be asked of you. So here in our first example, we have to calculate with reasons. We don't have to tell you with reasons, just by the way. Anything in geometry, you put your reasons there, please. Okay, and we need to go find what the size, what the value of x is. So we have ABC is a straight line. We have this 43 degrees, and then this symbol means 90 degrees. So in other words, those three angles, the 90, the 43, and the x. Because ABC is a straight line, you can plus them together and get 180 as an answer. And the reason you can do that, and that's very important in geometry, the reason goes from where you did something, or you had something that was visual, and you are turning this visual thing into algebra. You're turning it into an equation. This is where your reason goes, and the reason is because there are angles on a straight line. Then you go do your normal solving for x. So when we plus those together, we get 133. And then to get the 133 to the other side, because we want the answer for just x, we go minus the 133. So we get x is 180 minus 133, which gives you 47 degrees. Okay, you are also allowed to just from the beginning say x is going to be together, you know, all of them is 180, and you minus the 90, and you minus the 43. It would have gotten you the same answer. Also, just another note, you don't have to have a table like this. You could have straight on your piece of folio or wherever you are writing, just write the reason next to it. Or if you want to, you can put it in brackets, but it's not compulsory. So just note you don't have to draw a table for yourself every time. But I think a lot of people prefer it because it just like it looks nicer and it's easier to read. Okay, again, just note the reason goes in line with where you turn the visual into an algebraic equation. This doesn't have a reason because that was not geometry, it was algebra. Okay, let's look at another example where we are finding the value of x. This one is a little bit more tricky because if you look at the previous one, we only had the one variable and the rest were actual angle sizes. Now in this one, both our angles that are on the straight line have variables in them. So it makes it a little bit more tricky, but not undoable, right? So it doesn't really matter what they put there in the angle. You go copy and paste it. The one is 3x plus 20, and the other one is x. Now, because this is a straight line over here, and they're all like situated around point or vertex Q, you can plus them together and get 180 as an answer. Why? Because the two of them are angles on a straight line. Okay, again, just note here was 3 angles. It's still applicable because it was one straight line that share their point B as a vertex. Then you go add your like terms together. In this case, they are x's. So there's 3x plus 1x is 4x. Then we want the 20 to move to the other side. And we do that by minusing 20 on each side of the equation to keep it balanced. Otherwise, it becomes an inequality. Then we have 4x is equal to 160. And we don't want the size of 4x. They never ask for 4x. They ask for x, the value of x. We go divide by 4. And then we're going to get x is 40 degrees. Now let's just quickly go read the question to see if we answered everything they wanted us to answer. So calculate the value of x. Okay, we've done that. And hence the size of each of the angles on the line. Okay, this is why we read the questions. Don't do it like me and do it only afterwards. But do check. Okay, so then we have P, Q, S is the one angle. And the other angle is SQR. So SQR was just x, so that's 40 degrees. But you'll have to do a substitution to find PQS. So it's 3x plus 20. You're going to put the 40 there in x's place. And then we get 140. And you can double check. When you take 140 and you add 40, you get 180. Okay. So we didn't make a mistake along the way. Again, the only reason we had was here initially, because this was algebra and this was substitution. And then let's look at C. So this one is telling me to show that AC is a straight line. You cannot assume what they're asking you to show or what they're asking you to prove. Okay? If you've been taught by me, then you know I've said the story a lot of times. And it's one day, if you want to become like a lawyer, for example, and you must now defend this person for whatever crime it is, and you go up there and you say, Pity is not guilty because he is not guilty. I rest my case. And you go sit down. They're gonna fire you. Okay? You need to show your evidence, you need to show your calculations. So I know my ruler fitting on there and making it look like straight line is not a reason. Show your calculations in maths. Okay, so to prove a straight line, if we look back here, if you can find the angles that are on that straight line and get 180 as an answer, then it is a straight line. Well, if you find the angles on the line, then you can prove it's a straight line. So these are 3 angles. Let's go. In this case, I'm just going to add like a 1, a 2, and a 3 there just to make it easier to write. You are allowed to do this. Just do it on the answer book or wherever you are also writing your answers. Don't do it on the question paper and then don't hand in the question paper. Okay, where the person marking your paper can see. So we're going to add B1 B2, and B3. Okay, this is not geometric of geometry. This is just me adding the angles. And you see I started quite fancy. Okay, we start with the naming of it. Then we say 45, 80, and 55. Okay, we've now done our substitution. You put in your calculator or use your brain and you're going to get the add up to 180. Okay, you see everything is underneath one another. We're not making an equation. It's an expression, substitution, answer. So now we've found that when we plus together, we get 180 as an answer. So you can say that AC is a straight line. And the reason, this is now where the geometry comes in, is because the adjacent angles are supplementary, because we could have proven it. We just proved that it's 180. So therefore, it's a straight line. In the next video, we will look at vertically opposite angles.